As I was building this talk, this is easily not a lightning talk. It's probably a full-length talk. Not this talk, but the topic itself. So we're going to bulldoze through in about 10 minutes this stuff. So we're going to go through what Neo4j is, etc. So that's me. I'm Aaron Krauss. I'm the code boss on a lot of the social medias. So I work at a company called Clevyr with those three dudes in the back there and many other people. We're a software consulting firm here locally. We work with local clients for anything tech-related, websites, web apps, VR, AR, literally anything we do. Other than Clevyr, I'm also a code.org volunteer, so that means I get to go around to various schools and talk to their students about what it's like to be a programmer. I don't do that often, it's like once or twice a year, but today, for example, later today, I'm going to talk to the Edmond Public Schools STEM Advisory Council. Like I'm the professional programmer contact that they can ask any questions to. So if any of that sounds fun to you, you can volunteer at code.org's website. There it is. Okay, so getting into the topic, and again, we're going to bulldoze real quick through this. So am I a graph database expert? Neo4j is a graph database tool. It is an implementation of a graph database. No, I am not an expert. So we're going to go through this from a noob's perspective. That's what I am at most things. But I think it's really going to be awesome to see what the capabilities are here and how it differs from what you might expect with a relational database. So what is Neo4j? Well, that is the logo right there. So Neo4j is a graphing database or graph database. These are some bullet points. It's open source. It's a NoSQL database. It means it's not relational. It does not use SQL. It's been around since 2007, so it is not a new buzzword. It's been around. It is ACID compliant for everyone here who likes transactions in your databases. It has that. It's got cluster support, runtime failover, the generic buzzwords that make for a solid database. But what's a graphing database? What makes it different from a relational database? So this is kind of a nice graphic about it, and this is actually a Neo4j graphic. It is data that is related, but it's where it is significantly less structured. You don't relate tables and columns together. You relate actual nodes themselves, or what they're called. Actual data gets related to other actual data. So we're gonna dig into this. But if you ever I think this graphic right here is a perfect explanation of what a graph database is. It just kind of looks like a spider web of data. So Neo4j has everything it does revolves around three things, and it's called nodes, relationships, and properties, and that's how the data is represented. So this is, for example, this is kind of a little bit of data. Here we've got an employee that relates to a company, and that relates to a city here. So all the circles are nodes. Those are your actual, if you want to liken them to a relational database, those are your rows. That's where that's where most of the data is stored. So employee is going to have name, date of birth, employee ID, etc. Company is going to have company data, etc. Those are nodes. The bottom one of those things I'm going to hop back was properties. Those are just attributes. So again, going back to relational database, those are just going to be your columns. So name, date of birth, employee ID, those are attributes. The big difference is that there's another piece called a relationship, which you probably get what that is. You probably assume it's this arrow. Arrows can go any way. There's no concept of a foreign key or whatnot in a graph database. So a company can have an employee, but an employee, let's say they owned a company, for example, you could have a relationship here. And here's the big difference. A relationship is actually stored in the database itself. It's not an abstract key, if you will. Like, I'm not exactly sure of I guess this employee ID is just an ID of this, but you would never have a company ID on here that references this like you would in a relational database. In a relational database, relationships are made because there's no true concept of this arrow right here. You just have to query basically an employee of company ID 1, and that happens to match the primary key of this company. There's no direct relationship. It's all indirect, just IDs matching up. In a graphing database, they are direct. These relationships are actually stored in the database, and they can have properties themselves. So this relationship is called has CEO, and it actually has a property on it. So data relates to itself significantly more strong than you would in a relational database. This is kind of the big difference, in my opinion, and it leads to some really cool things, and we're going to do a demo of that later on. So let's talk about a little more about what it means to be relational, which is SQL more or less, versus a graphing database. So the key argument that graphing databases benefit are that your joins are very expensive and confusing kind of in a relational database. And they might not seem that way because you're so used to it, but if you're trying to explain to someone, why you have to join these 5 tables together, if you want to get these 5 columns out of these various tables, it's a tough argument to make. But again, we're so used to that mentality that it's not hard for us to think of that. It's just, we just don't have to think about it because we're so used to it. With graphing databases, you don't have to do that. And then also those, 5, 10 joins we're doing, they're very strenuous. We're having to query every single table to see what matches we're coming up with. There's no just linear way to get all the data, which graphing databases you can do that. Neo4j has a constant time traversal, so if instead of doing those 10 joins, even if the tables have millions of rows in them, it's going to be a constant time to get all of that data. And just with the nature of those relationships being in the database, if I need to find 1 record or 10 records, I just query for them, and then again, all that data is related to those nodes. I know I'm probably just changing your world if you've never seen a graph database before, but and I'm probably throwing out a lot of buzz phrases, but when we do a demo, it's going to be cool. So here's how we do a lookup in a relational database. We've got, if we wanted to look up what employees were under what departments, we have our employees table, a departments table, and then we have a join table in the middle, or an associative entity. That's the part that we can get rid of with a graph database. We don't have that join table. We just have an actual employee here. That's our node. We have more nodes over here, which are the departments, and then we just have relationships to those. So these relationships are called belongs to. They could be titled whatever. They can have whatever data on them, but we don't need that middle join table anymore. So Neo4j has a query language called Cypher compared to SQL. We'll just kind of show you an example of what it's like to get a name of everyone in the IT department. So kind of what we did right here. This is what a standard SQL query would look like. And it probably doesn't look that intense, but just look at it. We're trying to join a person to some join table. It's called person department. And then we're joining person department to the department table, and then we're saying where department is IT department. Here's what it looks like in Cypher. And it just, not only is it shorter, but it just makes sense. So, and I'm not going to go over the syntax here because I think it's relatively self-explanatory, but we're matching a person here. There's actually, you can see an arrow here, and this is the relationship name works at this department, and we're just saying the department name is IT, and then we're just getting back the name. So it's not SQL, but I think this is very easily readable, and I think if someone who was not a developer, they could probably read this a little bit, significantly easier than they could this, for example. So let's get to a little bit of a demo. I've got a little Python demo, which we're going to go through just very quickly in about 5 minutes. This is going to be our demo, but it doesn't have any data right now. So I want to just open up the Neo4j desktop tool. This is just one. This is the official Neo4j database tool to query data and all that. I've created my database. It should be it's just called GraphDB. I'm going to run this query right here. I don't know what the colon means in front. I think it just means some sort of command. But this is some actual Neo4j Explorer. It's like a little tutorial thing that I just ran, that play movies thing. So we're just going to create a movies database, which again, it's going to tell us exactly what to do here. And I'm going to zoom in a little bit so you can see it a little more. We're going to close that because that's not important. So let's just create some data first. Now, I'm going to copy this and put it up there, but I just want to show you this is what creating data looks like. And it's just, again, if you're not a developer, you're not familiar with this is still just very easy to understand. We're going to create a movie called The Matrix. Here's some properties on it. We're going to create some people who are actors, or they're not actors, actually. They may be directors, they may be supporting engineers, doesn't matter. And then we're going to create these relationships in here. Going to say Keanu acted in. Again, we're putting a role property on this relationship, showing that we can do that. Acted in The Matrix. It's very easy to understand from just a linguistic stance. So we're going to run that. I'm just going to click on that. We're going to run it. And then, again, this is the tool itself. We can kind of see that web spanning out here. So we just queried at the end of that create statement. I'm going to scroll just to the bottom here. We searched for something. Okay, we're not going to scroll all the way down. We queried like the top 10 list with like Tom Hanks or something. This is just a neat tool, part of the Neo4j browser. And if we wanted to see, let's just see if there were any other. Who else was in Apollo 13, for example? We can click on that, and we can span out that web there. So again, it's just a fun little way to see how a graphing database works, and I think this is cool to promote to other, especially non-developers, just that this is a much easier way to understand data than, for example, looking at a bunch of tables. And obviously, it's got its use cases. Like this is a perfect use case where we've got a bunch of movies and people, and they're related in various ways. You've got people directing movies, acting in movies. I think those are the major ones we see here. But when we start querying data, you'll see more. So we've actually populated our database here, and I'm just going to refresh this, and you see some fancy action going on there. That's actually not related to anything. That was just some of the client side. It actually builds this web of our data on the back, but we can't do anything other than just drag it around. But so for example, we just queried the matrix here. It found all the movies with the matrix in it, which I never actually knew that the Matrix Reloaded and Matrix Revolutions was made the same year. I have not fact-checked that, but according to this tool, apparently that's correct. So when I bounce around to these different things, we're updating data over here, and it's so easy to think that this might just be like a text field on the database, but it's not. This is actually a manifestation of all of the data on this. So the Matrix movie is an entity, is a node in our database. All of these people are just people in our database, and saying that this person acted in this as Neo, acted as this. These are all relationships in our database. So it's just something like this, where you just have data that is wildly related and potentially in a non-structured way, and you want to query it very quickly. This is where I think the graphing database just works really well. So again, I've got like 2 minutes left, and I haven't showed any code, so I'm just going to bulldoze through just some simple code so you can kind of just see how it works in Python. And we're just going to go through this. We're using just the traditional or the official Neo4j browser, driver to connect. It uses a protocol called Bolt right here. So just like HTTP is a protocol, Bolt is the Neo4j database protocol. So we're connecting to our database there. We're getting our database and closing our database there on Teardown. This is built using Flask right here. So if anything looks strange, like for example this decorator right there, that's provided by Flask. Flask being the micro web framework for Python, the biggest one. We're just serializing some data here. That's not important. That's not related to graph, to Neo4j. And here is just our first thing where we're actually getting data. Now this function getGraph this is getting all of the data from the whole database. It serves no other purpose other than just to build this fancy UI graph on the back. So we're getting all the data here, where you can see we're running a cipher query just as a string, the old school way of doing it. We're categorizing a little bit here, and then we're just going to return it. This one looks like it's a little bit more hefty, but when we actually are trying to query data, which is what we're doing right here, again, this is where we actually have a much more succinct query, and you can just kind of see we're trying to match a movie where the title is this, and then, yes, that's all the data we're getting there, and then whenever we actually are clicking on a movie, then we're actually getting some data about this movie, including the, all the relationships itself, all the people behind it. And I'm not going to dig into this too much, because again, lightning talk, I think this is a full-length talk topic, but more or less, this is it. I feel like this is more of a Neo4j talk than a Python plus Neo4j talk, but it's a whole wildly different way of thinking about things. And again, we're just running straight cipher queries in here. If you don't want to do this, which I don't think I would want to either, this is one of their official demos. There are other tools you can use. So just like you might be familiar with an ORM for relational databases, there's one tool called Py2Neo. I think that's just kind of a different way of writing, more or less writing cipher. There's another tool called NeoModel, which is an object graph mapper. So instead of object relational mapper, object graph mapper, which creates models as you might expect if you're more familiar with Django or something else similar to that. So I would probably recommend digging into kind of OGM tools, if you will, like this. But that's it. That's all I've got. I just think this is a wildly different way of thinking about things if you're not familiar with it, and it's really got its use cases. It's fast. It's not for everything, but for something where you have a significant amount of data that is very related and those relationships matter, I think you should check out a graph database. It's